You can visit our website for the commands in the videos. If you want to purchase other study materials like packet tracer files and other course guidelines, then you can email to us. Follow us on Facebook for further updates. Please do like, share, comment and subscribe so I can quickly deliver more videos on various topics. So next, I will show how to build this lab in packet tracer. So take the routers. So you can go select the router and 2621 SM as I always prefer. So I am taking two routers and switches 2960. And few PCs or printers, whatever. Server, just to show you. Okay. So next you can go to the cable and select crossover cable. Next you can go to the cables and select crossover cable. From router to router, same device, so you can use the crossover cable F00 and the other router also. And I can select either one of it. Okay, F00 or F01, whatever. For better understanding, we can use F01, so you can have a clear understanding on this. So next, just select the straight through cable. You can hold control and select the cable, so you don't need to come back again and again and select this one. Okay, so hold control and select the cable while selecting. After selecting, you can release the control. PC0, F04, F01, selecting. Yes, I can select even F05 or whatever I can select as 90%. Since these all are coming under same VLAN, I don't need to bother about the port numbers of the switch, right? So for the switch to router, I'm going for the fast Ethernet 0/24. And in router side, I'm selecting F01. Okay. Now you can see the routers and the switches links are in red, which means the links are down. You can give IP address and no shutdown commands to make it up. Okay. So we see what are the IP address we chose. For example, 192.168.10.1/30 here, and here again 192.168.10.2/30, and below you will have 192.168.12.0 and 12.1/27. Here also you can have 192.168.11.1/27, and for the PCs you can do anything which comes under 11. Okay, so simply 11. Even 10 and 11.15 we go for this, and 12.10, and you can go for 12.15 as well. Okay. So next, what are we going to do? For fast Ethernet 01, give the IP address. To save some time, we are going for the graphical user interface. Okay. Go to config F01 and turn it on. Give the IP address 11.1, and click on the subnet mask, you can see it will autofill with 255.255.255, which is /24. But here we are using /27, so you need to go for the 224, right? As I explained earlier. And also, this is via graphically we are doing it. By command, if you want to do, you can go check here, interface F01, and you can give the IP address command 192.168.11.1 and the subnet mask. Then you need to give the no shutdown command. This no shutdown command happened here because I have checked in this on icon. Okay, if you check this checkbox on, you will get the no shutdown command. Okay, that's what happened. That is via the command line interface. If you prefer to do it, you can go there and do it. And in config mode, you can do it quickly here. But in real environment, you need to go for the commands only. Okay, these are very basic commands. You can simply configure. Okay, and for the other one, F00, I need to give 10.1. So I'll show it by commands. So if I wanted to do it by commands, I can enter interface FA 0/0 IP address 192.168.10.1 subnet mask 255.255.255.252. Since it's /30, the subnet mask is 252. Enter it and give no shutdown. Okay. So this is how we will enter, and then go to the privilege mode, and you can simply type show IP interface list. You can see the IP addresses being assigned, and the statuses are up, and the first one 10.1 is in up down state. Why? You have only configured the FA00 port on router 1. You haven't done anything on the router 2 side, right? So when you give the command and give the no shutdown command on router 2's interface, then only this port will become up. Okay. So you can save your configuration as well. Type copy, run, and start. Okay, and enter. Or else you can give write or WR to save. Then go to the next router, enter inside command line. Whenever you get this initial config dialog, you need to give the no, right? Give it no, type in and enter. Okay, because we are going to configure manually. That is the auto configuration message. So enable show IP interface read. You can see there is no IP assigned and everything is in admin down state. Okay. Go to config mode and type interface FA 0/1 IP address. It's going to be 192.168.10.2. And subnet mask is going to be 255.255.255.252. Enter. And don't forget to give the no shutdown command. Okay. Now, once after you give the no shutdown, you can see interface F01 change state to up. This is called the syslog messages. We have a topic in syslog. So when we do that syslog stuff, you can recall this one. Okay. These are syslog messages. Whenever the system has any updates or any messages, it will show up here. Okay. And exit. And for the FA00 port, you need to give IP address. Interface FA 0/0 IP address 192.168.12.1 and 255.255.255./27 means you can imagine it should be 224, right? And give no shutdown command. again you get the sysdog message, and then you can press Ctrl and Z to get into the privilege mode, and here type show IP interface brief, and you can see F00 and 01 you are getting the 12. And 10. IPs what we have given. So next step, just save the configuration WR, and if you fast forward, or you can click here and fast forward the timeline, or else just press Alt plus D. Right. Next, we can try to give the IP address for our PCs, end devices or hosts. So now we can start assigning IP address for our end devices or hosts. Go to PC, desktop, IP config, and here type 192.168.11.10 and click on the subnet mask and edit the subnet mask by 25/27 means it's 224. Okay, and default gateway is going to be 192.168.11.1. Okay, likewise the other ones, desktop, or else you can go to the config, and here in the F00 port is the one which connected. Here also you can assign IP. IPv4, in the IPv4 you can assign 192.168.11.15 and click on the subnet mask and edit with 224. Okay. Then to add the default gateway in this method, go to settings, global settings. In settings you can see default gateway. In IPv4 default gateway, type 192.168.11.1. Okay, that's it. So if you do it here, if you go for the desktop IP config, you can see it's updated automatically here. Okay, it's been updated. Next, go to the server and add the 12.10. Subnet mask 224. 192.168.12.1 by 12.1 is the default gateway. Go for the printer. In the printer, to assign IP address, you need to go to the F0 port and assign IP 192.168.12.15 and give the subnet mask as 224 editing, and go to settings. In the settings, you can assign the default gateway as 192.168.12.1. That's all. So now we can check from this 11.10 PC how far you can ping up to which level, which means like 11.1, 10.1, 10.2 and 12.1. Just check whether you can ping up to which level, which IP address. Generally, you can ping only up to the 192.168.10.1. Why? We haven't configured any routing protocol in this router. Okay, go to command prompt, ping 192.168.11.1, the first one. It will ping. Okay, you can see the output. And next, up arrow and edit 11.1 as 10.1. That also pings, and 10.2 won't ping. Just try ping 10.2. If you type up arrow, you can get the last added command in command prompt. So edit it with 10.2 and you will get the request timeout. So as you can see, the request timeout message is coming. Why? there is no route protocol configured in the router. Either we can use static route or dynamic route. So now we are going to have a look at the OSPF configuration. So we'll try to write the commands first. Okay. For this router 1, let's say this is router 1 and the other one is router 2. Okay. So here for this router 1, what are the known networks? 10.192.168.10. and 192.168.11. So we just have to specify these networks only. And the command is going to be router space OSPF. I'm using a process ID of 1. So router OSPF 1, enter. Next you will write network, which is command, and give the IP address of the network 192.168.11.0, and the wildcard is going to be /27, means you are going to have the subnet mask as seen here, which means 255.255.255.224. So your wildcard mask will be 255 minus 224 is 31, right? So which is going to be your 11.networks subnet mask, wildcard mask. And what about the other one, /30 for the 10.network? So 255.255.255.252, right? So which is for /30. So the subnet mask is going to be 255 minus 252 will give you 3, right? So next you can see we are writing the command on OSPF. So router OSPF 1 is the first command. Second command is network, and give the network 192.168.11.0 space, give the wildcard mask of network. So 0.0.0.31, which is the wildcard mask, and space, and give the next area address. So which means you are going to type area space, give area 0 or area 1, whatever you can specify. Okay, just specify area 0 here. Okay. This is for the first network 11. Secondly, we will go for the 192.168.10. network. So type network space 192.168.10.0 space 0.0.0./30 means wildcard mask we saw, it is 0.0.0.3, and space area space 0. Okay, this is for the first router, which means the router 1, and you can copy all this and again paste it and modify for the second router, router R2. So router OSPF 1, or you can choose router OSPF 2 even, because in OSPF the process ID doesn't have to match. In EIGRP the process ID have to match. Okay. Next, after router OSPF 2, you need to type network 192.168 10.10 12.r here in router 2. So edit it with /27 is the 12.1, so edit it with it 12.0, and the wildcard mask is correct 31, and for the other one 10. You can specify the wildcard mask is also correct, so you don't need to edit that command. Okay. So now we have written router 1 and router 2's commands for the router OSPF. Okay. So simply you can copy these, go to router 1, so inside the config mod, enable config T, just paste the commands, that's enough. Okay. Control Z and WR to save. Likewise, copy the router 2 commands, copy it all, go to router 2, enter the config mod, enable config T, just paste the commands, control Z and WR. Okay. So now you need to fast forward a few times so that we can figure out OSPF packets has been exchanged with router 1 and router 2 in between. Okay. So Alt D. Here the time will be increasing. It's being forwarded. Okay. So now in router 1, just type. You can see the message OSPF process 1 from loading to full state. Okay. So this OSPF states you will be understanding when I explain the OSPF process in between routers. Step by step, I will explain the theory that we can see in the upcoming videos. Okay. So if it is showing full state means the network has been converged. So you can ping from one area to other one. Okay. So the other router also, you can see the full state command has been there. Just enter the privilege mode and type show IP OSPF neighbor, which gives you who is your directly connected neighbor, okay, via OSPF. So you can see the neighbor's router ID is 12.1 and he is in full state and connected to the interface on F00. Okay, so and priority 1 bit here. So likewise in the router 2 also you can type show IP OSPF name. Okay. So router 2 is having 11.1, which is router 2 1's IP address, and full state again it is having the address of 10.1 in the other side, which is fast internet 01 port connector in the local interface. Okay. The interface is local interface and the IP address is the opposite neighbor's IP address. Okay. And this one neighbor ID is the neighbor's router ID. Okay. Which I will explain when we look at the OSPF theory. Generally, the highest physical IP address will be chosen as the router ID. If you have logical interfaces like loopbacks, then the highest loopback IP will be chosen as the router ID. Okay. So now you can check the route table as well. Entering show IP route OSPF, or else just simply type show IP route. You can have all the routes. Now by typing OSPF command in the end, you can have only the OSPF routes filter. Okay. So you can see the route table is having this network via OSPF 11.network and 12.network, sorry, and type show IP route. You can see the directly connected networks and the OSPF network. In router 2 also you can type show IP route. You can have all the route table details. You can note that gateway of last resort is not set, and also to see only the OSPF route, show IP route OSPF. Okay. OSPF maintains neighbor table, interface table, database table, like that. Okay, you can try those commands as well. Simply, if you forget any commands, you can start like show IP and you forgot the next command. So just type question mark. You will see the options. So access list is there, OSPF is there, protocol is there, read, everything is there, and route also there. So we go for show IP route. Next option again space question mark. here you can find OSP, show IP route OSPF or RIP or static or summary, whatever. So we'll go for the OSPF. And again, you can space and you can type space and question mark. Okay. Here, if you see the CR, which means you can press enter and finish the command. Okay. Or else you can try these other options as well. So I'll just finish the command and see my OSPF route. Okay. So now, commands wise, we checked everything, and we go for the summary as well. Okay. You can see the route summary, and then we start pinging from PC 11.10 to printer 12.5. Okay. One 12.5. So initially few packets will be dropping, and then you will get the ping output. Okay. Initially it's request timeout. Why? Because it's because of the address resolution protocol, ARP. Okay. Okay. So again we will try. Actually it is 12.15, right? In the printer I have given 12.15 and I am trying to ping 12.5. That is why I got the request time. I didn't notice that. So I have to type 192.168 12.15. So now the initial few packets will be request timeout and then it will start pinging. Okay. This is what the output, and then earlier you can notice it didn't ping 192.168 10.1 even, right? Why? There wasn't any route protocols. Now there's a route protocol. 10.2 wasn't pinging earlier. Now the route protocol is there, so it can ping anything. So ping 192.168 10.2, it will start pinging. And you can see the continuous ping by ping space minus t space 192.168 12.15 or 12.10 for the server who can ping it. Okay. Okay. You can see continuously the packets are pinging. Let me show you what happens if there is a link failure in between. You can notice here the packets might drop. Okay, so let me just temporarily turn off this F00 interface for a while. Go to config and you can check this as well, and we need to monitor the ping as well. Right? Continuous ping is there, and go to 00 and just turn it off for a while. So you can see here there must be a packet drop. Okay. You can see request timeout and destination unreachable message is coming. Why? Because we have turned this link into shutdown status, so it's being packet drop and destination time unreachable. So now again let me turn it on and see. Slowly turning on, and it must become greener to make it up. So we need to wait, or else we can fast forward here. inside. Now the link has been turned green. So soon the packet must ping. Okay, you can see it's starting to ping. Okay. So this is how the output will be. So whenever link goes down, the packets will get dropped. So in real life, we will start using this continuous ping command in cases like this. Okay, to figure out what is the links down or what are the cables going to the switches and all. We can check like this. Okay. And now press Ctrl C to stop this continuous ping. So we have covered our OSPF configuration with area numbers. Okay, we have done in the same area. In another lab, we start doing for a multiple area OSPF. You can check it here. Okay. You can visit our website for the commands in the videos. If you want to purchase other study materials like packet tracer files and other course guidelines, then you can email to us.